Okay, so here we are. We're doing topic 5.5, and it's getting late. I just got back from the Florida game. It was a good game, halftime close. I don't know how it finished because I had to go get my daughter from dance. But anyway, here we go. We did the EMF, and then we did the series circuit. Now we're going to go over a parallel circuit. This is quite simple, parallel circuit. What we're going to talk about is the voltage, current, and resistance characteristics of a parallel circuit. So here I have a parallel circuit set up. The first thing I want you to notice is, what if I were to put a voltage probe, like a voltmeter, right here, and that's my voltmeter, my little meter. Can you see that would be just because of this wire right here that basically, let me get rid of that excess. It would just be like they're hooked up to the positive and negative sides of the battery, or the source, and so therefore I'd be measuring the voltage of the source. And then can you see that if I were to put the wire here, then I would also be measuring there would be a direct link via wire back to the positive and negative sides of the terminal, and I can put it anywhere in there and it would be the same. So what I'm trying to get at is that the voltage throughout a parallel circuit is the same. So the voltage of the source is the same as the change in voltage across R1, which is equal to the change in voltage across R2, which is equal to the change in voltage across R3. So there you go. There you have it. And so that's pretty simple. So there's what our voltage characteristics are like. The voltage is the same. So consequently, think about that. What would happen if you were to run a battery running 3 light bulbs, for instance, instead of these resistors R1, R2, or R3, but if you were going to run 3 light bulbs, each one would get the same voltage, so it would wear down the battery much faster. Also, compare that with the series circuit. What if we were to cut the wire right there? Well, now that last branch would not work, but the other 2 would. So this is how your house is wired up, basically, in parallel, and that means that every outlet in your house gets 120 volts directed to it. So that way every appliance can be based off of 120 volts, like we talked about in class. Excuse me. So there's the voltage characteristics. Let's move on to the current characteristics. So let's start talking about current. If you were to think about this, if you had an ammeter or a meter, and you wanted to look at the current, remember we got Ohm's law, V equals IR, and if we were to look at the current, that therefore I would equal V over R. So we've already got an answer to what V is like across R1. What would that would read the same anywhere if I were to put one here. So anywhere along here, I would get the same voltage reading, we agreed. And so let's take a look at what the current would be. So that means, current up here in the upper right is equal to V over R. Well, if you took V over R1, you would get the current through R1. V over R2 would be the current through R2, and the same it would be for R3. Now the only way they'd be different currents is if the R1, R2, and R3 were different values of resistance. So, but what I'm trying to get at is that the total current here, if you were to measure the current going into the circuit, it's actually divided up amongst the 3 branches in the parallel circuit. So the total current, so this current right here, so let me put this in terms of water. So what if you had 5 gallons or let's do liters, 5 liters of water per second going right through here into the circuit from positive to negative, conventional current. And so that 5 gallons of water would be divvied up amongst these 3 branches. Imagine these were pipes. And then back over here on this side down here, you would have 5 liters of water per second going through if that was your rate. So that's like your current, because current is a rate. And so you would have some current here going through this branch, some current going through this branch, and some current going through this branch. So that's pretty simple. So therefore, what we can make a statement about the current. The I total is equal to the I through R1, which is equal to the, sorry, I said equal. I wanted to have plus the I through R2 plus the I through R3. And in other words, we add up the current here, I1 plus I2 plus I3. So finally, we're just going to make a quick statement about the resistance, and then we'll be done. So I'm going to go to the next page, and so we say I total equals I through 1 plus I through 2 plus I through 3, and we remind ourselves that I is equal to V over R. So if I total would be would be V of the source over R total. And if we go back and remind ourselves, oh no, we're getting to that, okay. And then we can write this one. So this would be I through R1 over R1 plus I. Oh, what am I doing here? Just a minute. Sorry. This would be V through 1 over R1, and this would plus V2 through R2. That would define the current, because all I'm doing is I'm defining this equation in terms of V and R because of this. I'm just putting it in terms of V and R. So let me see if I make a better plus sign there. And then plus V3, that's the voltage across V3, the voltage drop over R3. Now remember from the previous rule that all the V's are the same, so these would all cancel out. You could, because they're numerically all the same, so you would have 1, 1, 1, and 1. So you'd have a new equation that looks like this. 1 over R total, sometimes referred to as R equivalent. R little equivalent for R total. You can probably more commonly referred to that way. Equals 1 over R1 plus 1 over R2 plus 1 over R3. So this is how you'd find the total resistance in a parallel circuit. And don't forget to take the reciprocal. That's an I right there. Hope I got that right. Reciprocal. Okay. Of 1 over R total equal to 1 over R. And so when you add up all this side, you have to take the reciprocal to get R total. So not many students will leave it as 1 over R total equals the sum of these ratios here, 1 over R1, 1 over plus 1 over R2. Anyway, that's it for parallels. We're just going to cover a little bit each night, and so we'll put all this together tomorrow with a brief discussion at the beginning of class to make it you a little bit more aware of what's going on. All right? Good night.